Hello, so today we are going to do this problem, which is part of this bi-weekly contest, maximum number of integers to choose from range 1. So basically we get a list of banded for array, and we get two integers, n and max sum. And we want to choose an integer between 1 to n with the following rules, right? It has to be in the range. We can pick it only once. It has to not be in the list of banded numbers, and the total of the overall numbers we take needs to not exceed max sum, right? And this is and we keep taking numbers like this as long as we don't exceed max sum. And the goal of the problem is to return the maximum number of integers that we can choose using this rule here, right? So for example, if we take a look at banded here, it's this, and n equal to 5. That means we can take from 1 to 5. And so let's just take, for example, 1, we can't take it because it's in band. So we take 2 and 3, that's 5. We can't take 4 because that exceeds the sum. So we can either take 2, 3, right? Or take 2, 4. Okay? So that's what, but regardless, that the maximum we can take is 2. Okay? And similarly here, but here because all of the numbers are in band and the maximum sum is 1, all except 8, and the maximum sum is 1, we can't take any number, so return 0, right? So that's roughly the idea. Now this solution should be pretty straightforward, right? What's the easiest way to solve it is just to go through all the numbers, and if the number is not in band, and if the total sum is not yet exceeds max sum, we can just take it, right? Just count it. But the other thing to think about here is that this is a list. So if we just check in band in the list, that would be O of n operation. So how do we make it O of 1? Well, we can just convert the list to a set, right? And so to do that, we can just have banded set and just convert it to a set. And this way we can go for the numbers. So let's call it x in range of 1 to n. So in Python that would be like this. Now this works because we'll take the smallest number first, right? And the smallest number will maximize the chance to get the maximum number of integers, right? And so that's why this works as well. And so here we need both something to keep track of the sum, and we need something to keep track of how many we took, right? So and then we can just check if the number is not in band. So just applying the rules, we want to make sure that we didn't exceed the max sum as well, right? And so to do that, we want to check that if total plus this value exceeds max sum, then there is no need to proceed, right? Because as we go higher, we will only find bigger values. And so if this value is bigger than max sum, that means if you go to the next x value, it will be bigger as well. So here, we should just return how many we've got so far. But otherwise, if it's not in band and the sum doesn't exceed max sum, then we should just add it. So we add x to total, and we increment the number of numbers we took because we just took x, right? And so at the end, we just return count. Okay? That should be it. Now if we run this, should work. And it does, right? Okay, so this is pretty much it. In terms of time complexity, we are doing this O of n loop. So it's O of n, but we are using this extra space, so it's O of 1 space, right? Yeah, so that's pretty much it for this problem. Pretty straightforward. Please like and subscribe, and see you on the next one. Bye.